Hello, my dear students. Here, very interesting question. It is that, so 35 ml sample of H2O2 gives of 494 ml of O2 at 300 Kelvin and 1 atmosphere pressure. What will be the volume strength of H2O2 sample? So this question you can able to solve after watching this video, and after watching this video, please try to solve this question. And if you get the answer, post your answer in the comment box. And if you have the detailed explanation, you write it on the paper and post it in the comment box. Thank you. I'm waiting for your answer. If you give correct answer, I will give the reply. And if you give wrong answer, even though I will give the reply, so please don't forget to post your answer in the comment box. Thank you. Hello, my dear students. Welcome back to SHLOKA'S Academy. In this video, we are going to discuss volume strength of H2O2. Usually, the concentration of H2O2 expressed in terms of volume. What is meant by this volume? So here, we can see in this image, this is the bottle of H2O2 where it was labeled as hydrogen peroxide solution 6% or 20 volumes. What is meant by this 20 volume exactly? Right. So that is what volume strength of H2O2 and today's topic. So exactly 20 volume of H2O2 means 1 ml of this H2O2, 1 ml of H2O2 gives or releases 20 ml of O2 at STP. Or you can also take 1 liter of 20 volume H2O2 gives 20 liter of O2 at STP. This is what the exact meaning of 20 volumes. If it is 30 volume, what does it mean exactly? 1 liter of 30 volume H2O2 can give 30 liters of O2 at STP. Or 1 ml of 30 volume H2O2 can give 30 ml of O2 at STP. So in the similar way, so let us assume, let the volume strength of H2O2 be X volume. It means that, what does it mean exactly? It means that 1 ml of this H2O2, whose volume strength is X, H2O2 gives X ml of O2 at STP, right? Now let us take the decomposition, the dissociation of H2O2 to give water and oxygen. Let me take 2 moles of H2O2, which is dissociated to give 2 moles of water and 1 mole of oxygen. According to this balanced equation, what we can say, if it is 2 mole of H2O2, how many moles of oxygen we are getting? 1 mole. If you take the weight of H2O2 we have taken here, it is 2 into, what's the molecular weight of H2O2? 34 grams. It is giving 22.4 liters of O2 at STP. At STP, right? Or you can also take 2 into 34 grams can also give 22,400 ml of O2 at STP. But what I took, the volume strength of H2O2 was X ml. That means if 22,400 ml of O2 has been released by 68 grams of H2O2, what would be the H2O2? What would be the weight of H2O2 that can release X ml of O2? X ml of O2 at STP can be released by how much weight of H2O2? So that we have to discuss weight of H2O2 that can release X ml of oxygen at STP is equal to 2 into 34 into x by 22,400. Otherwise, you can write 17x by 5,600 grams. Means this much of H2O2 can release x ml of O2 at STP. So here I want to know the strength of the solution. Strength of the solution. So what is the strength formula? Tell me. Strength of the solution is equal to volume in ml. Sorry. Strength of the solution is equal to weight of solute. Weight of solute in grams by volume in liters. That means grams per liter. This is what strength of the solution. Now from this we can say that 1 ml of H2O2 contains 17x by 5,600 grams of H2O2, where in 1 ml of H2O2 there is 17x by 5,600 grams of H2O2. Then what would be the weight of H2O2 in 1 liter? That is 1000 ml. So from that, what we can say, tell me, 1 ml of H2O2 contains 17x by 5,600 grams. Then 1000 ml, that is 1 liter, H2O2 contains how much? That will give us strength of the H2O2 solution or not. So now what you can write, therefore, strength of the solution is equal to what you can write, 17x by 5,600 into 1000. 1 ml, this much means 1000 ml means 1000 into this much. So that will give us 17x by 5.6 grams per liter. This is what strength of the solution. And we know the relationship between strength and normality. We know that strength equal to what? Normality into equivalent weight, which is equal to 17x by 5.6. Here, what is the relation between strength? Strength equal to normality into equivalent weight. So from this normality, what is x here? What is x? Volume strength. I want to know the volume strength of H2O2. Volume strength of H2O2 equal to what you can write, tell me, normality into equivalent weight of H2O2, right, into 5.6 by 17, not x, because x is a volume strength of H2O2. This is what x. Now tell me, what's the equivalent weight of H2O2? Its a molecular weight is 34 and its n factor is 2. So its equivalent weight would be 17. So this 17, I can write n into 17 into 5.6 by 17. 17 get cancelled. So now volume strength of H2O2 equal to normality into 5.6. So this is how, when normality is given, how to find out volume strength of H2O2. And from this, we can also derive another relation. We know that molarity and normality relation, molarity into n factor equal to normality. For H2O2, what's the n factor? 2. So normality of H2O2 is equal to molarity of H2O2 into its n factor 2. Substitute here. Then volume strength of H2O2 is equal to molarity into 2 into 5.6. That is volume strength equal to molarity into 11.2. This is the relationship between volume strength and molarity of H2O2. Right? Here till now we have got two relations. One is normality and volume strength, and another one is molarity and volume strength. Right? And what is strength of H2O2? Right, strength of H2O2, already we know that it is 17 by 5.6 into volume strength. This is another one, right? And normality already we did. Normality is equal to what you can write, volume strength by 5.6, molarity is equal to volume strength by 11.2. This is how we can find the volume strength of H2O2 when they gave normality or molarity in the question. Right, now let us solve some example questions on this volume strength, how they are going to ask the questions on this. Okay, let us see the example. In this example, they have given a fresh H2O2 solution is labeled 11.2 volume. This solution has the same concentration as a solution which is, means among the given 4 options, we need to find out the concentration of these 4, which is exactly equal to 11.2 volume strength. So for this, first what we should do, what is the given data? Volume strength of H2O2 solution is 11.2. So find out its molarity or normality, whatever it may be. So what's the relationship between volume strength and normality? Volume strength equal to normality into 5.6. That just we have discussed. So from this, volume strength is 11.2 equal to normality into 5.6. So what do we get? Normality as 2. This is 2 normal solution. Now, if you want to derive the relationship between percentage W by W and normality, compulsory one more term is needed, that is density. But in the given data, there is no density. So this is not our correct option. And if you want to give the relationship between volume and strength of the solution or normality, it is not at all possible. So it couldn't be the correct answer. But here, this is percentage W by V, weight by volume percentage. So that we can give the relationship between normality and percentage W by V. What is percentage W by V? Tell me. It is nothing but weight of solute by volume of solution into 100. This is percentage W by V. And what is normality? Weight of solute by equivalent weight of solute into 1000 by V in ml, volume of the solution in ml. Now the same normality I can write weight of solute by volume of the solution in ml into 100 into 10 by equivalent weight of solute, that is H2O2. So this entire part I can write it as percentage W by V, weight by volume into 100. So normality is equal to percentage W by V into 10 by equivalent weight of solute, that is H2O2. Now from this, what's the normality here? 2. So percentage weight by V is equal to normality 2 into equivalent weight of solute 17 by 10. How much you will get? 3.4%. So what's the right answer? The right answer should be option C. This is how we can solve the question based on H2O2 volume strength. Let us move on to the one more example of this type. Okay, here we have second example, which is quite interesting. So in this question, they have given that bottle A contains 320 ml of H2O2 solution, which is labeled as 10 volume, right? And bottle B contains 80 ml of H2O2, whose concentration, that means molarity, is 2.5. Now we have connected bottle A and bottle B, and they are mixed, and solution is filled in another bottle C. then what should be the correct labeling for bottle C in terms of volume strength? So let me take two bottles. This is bottle A, right, and another bottle B, and another bottle C. What we are doing here, so in this bottle, what's the volume of, first they have given what is that volume strength of the H2O2. So what is the volume strength of H2O2 in bottle A? 10 volume. So from this I can find out molarity of bottle A. So molarity into 11.2 equal to volume strength. So from this molarity of H2O2 in bottle A equal to, so volume strength 10 by 11.2, right? And what about the volume of the H2O2 solution in bottle A? Let it be VA. VA is equal to 320 ml. Let it be. This is in bottle A. In bottle B, already they have given the molarity. So what is the molarity in bottle B, which is 2.5, and what's the volume, which is 80 ml. Now we have the formula molarity upon mixing. What is the formula molarity upon mixing? So molarity upon mixing is equal to MAVA plus MBVB by VA plus VB. Means M1V1 plus M2V2 by V1 plus V2. So molarity of mixture in the bottle C will be MAVA, means what I can take 10 by 11.2 into 320 plus MBVB 80 into 2.5 by 320 plus 80, 400. If you do this, what should be the molarity you will get? Tell me, just a minute. 10 by 11.2. Which is equal to 0.892. 0.892 into 320. Which is equal to 285. Here I can write 285 plus 80, 160, 40, 200 by 400, which is equal to 485 by 400. How much you will get, tell me? 400 by, 485 by 400, which is equal to 1.25. 1.2125. This is molarity of the mixture in bottle C, which is equal to 1.2125. Now I know the molarity, but I need to find out the labeling of bottle C in terms of volume strength. So what's the relationship between molarity into 11.2 equal to, what is that, volume strength or not? I want to know the volume strength. So molarity how much? 1.2125 into 11.2 will be the volume strength of the bottle C. So what is that answer? You can do it. So this is how various examples we can solve based on what is that volume strength of H2O2. So here I am giving you one question. What is the question means? So you do it and post your answer in the comment box. Below the video link, you can post the comment. So your answer should be posted in the form of comment. I will give the question here.